So it says the concentration of 1 molar of weak acid HNO2 is 2% ionized, and the pH of the solution is 1.7. What happens when KNO2 is dissolved in a solution? You should probably pray.
Yeah. Heavenly Father, we're grateful for this day and for the education we're receiving. Please bless us that we'll be able to go over this material and be enlightened and be able to understand and that the Spirit will be with us. And we say these things in Jesus Christ's name.
Thanks. So, okay. Start off with this concentration of this weak acid. So I'm going to write down this weak acid in my equation, HNO2. And this weak acid is going to be reacting with probably OH. I'm thinking if we're doing buffers and stuff. I don't know. What order are we doing? Is ionized. What happens when that is dissolved in the solution?
Okay, so a weak acid,
Mm-hmm.
put in, right? 2% ionized.
What's that mean?
So like becomes ions.
Oh, okay, 2% of it dissociates. Gotcha.
Basically.
Gotcha. It's the weak acid. That makes sense. Okay, I guess I kind of understand that conceptually. Then, what else? And the pH of the solution is this. What happens when this is dissolved in the solution? Well, this might actually, like, I think when that's dissolved in solution, it might promote that more of this forms back, because there's going to be loose H's everywhere, or like a little bit of loose H's anyways.
Right?
Yeah.
And you're putting in KNO2,
Mm-hmm.
which is just this once it goes in solution,
Okay.
because it's dissolved in the solution. So you put it in and it
Yeah.
dissolves. So you're basically adding this.
Yeah.
So
So the
your idea
reaction
was
is
right.
going to go that way, and it's going to become more acidic.
Well, it's just saying the extent of HNO2 ionization. So
So that
how much
actually
of this is ionized?
less
Will it be more or less?
less
Yeah.
decreases.
I don't think I've ever
The
seen
concentration of H is going to, well, if you're just adding this to that side, it's going to have to increase to make up, so it's going to increase, right? Well, it's
Of
not H plus
plus.
ions, no. It's
So
that-
H
it's
plus,
that.
so this when it dissociates in
Yeah.
water, right?
Okay, gotcha. So it's going to be decreasing as well because the HNO2 ionization is decreasing. And then the pH, because of the concentration of H's decreasing, is going to become more basic, which is going to increase.
That's what I'm saying.
Nice. Dude, I'm a genius, right?
There we go. A plus. I just told Brother Haber. He doesn't need to take the test.
Doesn't need to, I passed him. Thanks. Okay. Which pair of compounds will form a buffer in aqueous solution? Well, things will form a buffer in aqueous solution when they. I'm trying to remember. Is it an easy? A buffer. It's going to make, well, generally I've seen it make a lot of, it has water on one side of the reaction.
So what is the purpose of a buffer?
A buffer's purpose is to kind of like barely change the acidity or basicity of it, something.
How basic.
how basic it is.
Okay.
And so.
Right.
And so like if this is, which pair of compounds in English? So like HCN is a weak acid. And so if I put HCl in there, that's a strong acid. And that's actually, it's going to, I want to say it's this answer.
Okay, so let's think. Okay, let's look at the first one.
Okay.
This is how we should go about it. So buffer, what do we want? We want a acid with its conjugate base. Because then if we put,
Oh, you want, the buffer is the conjugate base.
so then we have like,
Or no?
let's just put this for example.
Okay.
Oops.